Hey class, in this PowerPoint, we're going to cover two subjects. We're going to cover battery testing, and we're also going to cover starter testing as well. Okay, so this is going to be part one right now. I'm going to go through this PowerPoint rather quickly because there's a lot of information to cover, but mostly I want to touch on the most important things, okay, and not get too much into the weeds of everything. So the first thing, if a battery can be serviced. Now why do I say if? Because there are batteries that are sealed. They're maintenance free batteries. If a battery is maintenance free, we don't add anything to it. We don't touch it. We just use it. And when it is time to replace, then we replace it. That's it. Now, if a battery is not sealed and does require maintenance, the only maintenance we can really do on the battery besides cleaning it is adding water to it. Now, if we are able to add water to a battery, we want to add distilled water, okay? We don't really want to add, sorry, I moved the slide, but I moved it back. We don't want to add clean drinking water. Drinking water has minerals in it. It's good for us, but not really good for the battery. So distilled water is the recommended type of water that we want to add to a battery if the battery can take water. You know, if it's a maintenance battery, if it's a maintenance-free battery, then we don't add any water to it at all. Okay, the one thing we can do with all batteries, no matter what, if it's maintenance-free or maintenance battery, is clean it, meaning we can clean the terminals. Now, these terminals here, you can see there's this like buildup here, this white buildup, looks like powdery type of substance. So as the batteries are aging and some of the gases escape, they escape through the seal of the of the terminal here. So they'll escape around here and they come in contact with the air, and then they forms this chemical reaction, forms this this powder looking stuff here, okay, or fuzzy stuff if you want to call it. Now that's what we can clean. We can clean that off, okay, and that's good to clean out. We should clean that off, whenever you see it, roughly every, maybe check it every 3 months, clean it every 6 months or so to say. It kind of depends on the battery. Sometimes you don't have to clean it for like say the first 2 years. It really doesn't get dirty. And then all of a sudden, as the battery starts to age, you start to see that more. So you want to clean that off. Okay. What the person is doing over here on the right side is they are cleaning it, but they're cleaning it using Coke or Pepsi. We can use a carbonated drink. It doesn't have to be Pepsi or Coca-Cola necessarily. It can be, Sprite or 7-Up or anything that's carbonated. It could be carbonated water. The thing is, it has carbonation. So we could use that to clean it. Is that recommended? Not really, because they do make cleaning materials. They make cleaning sprays for batteries. They're available at the auto parts store. Just go buy them, spray it on there. They're like maybe, $8, something like that for a can. The can will last you for a long, long time. And you just spray it on there and you wipe it off. You can use a wire brush and everything, but those are the terminals is what we're going to clean on all batteries, regardless if they're maintenance free or maintenance batteries. Okay. The other thing we're going to do, if we go back to when we talked about batteries, the full voltage battery is full 100% voltage is 12.62 to be exact. If we do 12.6, that's fine. That's when we know the battery is 100%. So the battery over here on the left is 12.28. So it is roughly about, what is it, around 40%, I would say, something like around there. Because 12.4 is 75, 12.2 is 50. Yeah, I would say this is more like closer to be like 60%ish, somewhere around there on the one on the left, the picture on the left, okay? And then 12.0 is really 25% if we go back, okay? And we look at what the actual percentages are. It goes down really quick, okay? We want to check the battery voltage as far as using a meter to just quickly check it when the car's off. This is when the car's off. If the car was on, we would be getting alternator voltage, okay? We can use a hydrometer also, which can test a specific gravity. So if we remember, the specific gravity of a 100% charged battery is roughly 2.62, 1.61. Sorry, let's try this again. 1.625. I circled it down here. Okay. 1.265. Now that is a fully charged battery. Now we don't really do this very much because on a sealed battery, we can't even get to the electrolyte, so it doesn't matter. We can only do this on a non-sealed battery, meaning a maintenance battery where we can add water, but you would need that special tool It's not something I recommend you go buy. There's battery testers that are available, and we don't really need to test it. But make sure you write down. We don't need to test it this way, but make sure you write down the notes there. Okay. Again, this is just kind of recap from when we learned about a little bit about batteries. The CCA, NCA, and RC. All right. So if we were to load test a battery, which we really don't do anymore, if we were to load test it, we would test it at half the CCA. Okay. Half. We don't want to use full. We want to use half. Okay. Roughly. Now, we don't really load test batteries anymore, though. I just want to make that clear because if the reason we don't is because all the computers on the vehicles, but if you ever ask a question, we would want to do half. Okay. Half the amp hours. The batteries, if we load test a electrical system, what we're doing is we could create voltage spikes within the system. We could damage control units and stuff like that. So those are the reasons we don't really test batteries anymore. Now this slide here is showing two batteries wired in parallel. Now, if you're going to work on a diesel truck, and it doesn't have to be a huge, big diesel truck, what I'm talking about is like a Ford F350, 250 or 350, a Chevy 2500 or 3500 diesel truck, or a Dodge Ram 2500 or 3500 Cummins diesel. Now, all those trucks I just named, they have two batteries. They have two 12-volt batteries, but they are wired in parallel. So the whole system works at 12 volts. But the reason we have two batteries is if we wire them in parallel, we increase the amperage, which is the amount of electricity. A diesel engine has very high compression ratio. And in order to get the engine to turn over when we're first starting it, we need a lot of amperage. And that's why they have two batteries. Okay. On the big trucks, the big diesel trucks, like the Internationals and the Peterbilts, like the ones on the freeway that are hauling big giant trailers, they have four batteries. They're still 12-volt systems, but they have four batteries wired in parallel. And that, again, is to increase the amount of amperage to be able to turn over those big giant engines because they have such high compression ratios and so have such big components inside of them. Okay. So that's where we would encounter parallel batteries in a diesel truck 3500. um, Parallel. So if we have two batteries in parallel, sorry, in series, if we have two batteries in series, we would have 24 volts. So we're increasing the voltage, but the amperage is staying the same. So the only ones that really do use this are buses. So buses often run off 24 volts. Okay, transit buses, so OCTA, buses like that, they would have 24 volts. Sometimes they would have four batteries, two of them wired in parallel and two wired and then the two pairs wired in series. So you still get 24 volts, but you're getting increased amperage, not as much as if you wire them all in parallel, but a step up, so to say. Okay. So there's different ways to wire batteries inside vehicles. You know, on our vehicles, we're used to just one battery, and that's how most cars are. Okay. We're talking about if you see a parallel battery setup or a series battery setup, you're talking about heavy duty vehicles. Now, this is your basic conductance tester. This conductance tester is what we use to test batteries. Very, very simple. Okay. There's multiple companies that make these, Matco, Snap-on. This was made by Midtronics. I'm sure there's other companies like Innova that may make them as well. Okay. There's different companies that make different ones. They all relatively do the same thing. They are a conductance tester. Conductance means testing the internal resistance of the battery to see if it's good or bad. That's all it does. It'll give you a rating. It'll tell you bad battery, good battery. You know, it could tell you how much is left, how much life is left of the battery too. You connect it to the terminals, car's off. It's going to ask you questions. Mainly it's going to ask you what the CCA is. You enter the CCA, whatever it says on the battery. That's why we need to know that. And then you hit test. A couple seconds later, it goes through its little uh, diagnosis process. A couple seconds later, you have a printout. You have some data that tells you if the battery is good or not, and tells you what this charge is usually, and it may even tell you what the percentage of life left is on it. Okay, and then by that you're determining if the battery is good or bad. Are these things reliable? For the most part, they are. Uh, I have seen where they'll say the battery's bad, then you go and charge the battery, then it comes back, you test again, then it tests good. So does that mean the battery's bad or good? It means that it's getting close to where it's the point where you may need to replace it soon, say within the next, say 6 months or so. Okay. If it tests good all the time, good, the battery's good. You can use this to test the battery multiple times either throughout the day or throughout the week. And then, you can average, if it's always testing good, then you have a good battery. If it's testing good 50% of the time, testing bad the other 50% of the time, then all right, your battery's probably going bad at that point. It's not bad just yet. You probably have a little bit of time on it, but at some point within the near future, you're going to want to look to buy a new battery. And that's what we're looking at. Okay. Charging. So if we want to charge a battery, there's a couple guidelines here. Make sure you write these down. I'm not going to go over every single detail, but when we charge a battery, we can charge it at different amperage ratings. Meaning, if we want to say charge the battery really, really fast, but at high amperage, we can do that. Or if we want to trickle charge it, which means charge it slowly over time, we can do that as well. Now, if we charge a battery really fast, we can charge it at 60 amps, but I would only do it for, say, like 10 minutes at the most, maybe even less. Um, you know, that's one option. The other option is to charge it at, say, 5 amps, but we can do it for 2 hours. Which is better? The the slower way is better, but it takes a lot longer. Okay, because the slower way, if we only charge it at 5 amps or 10 amps, but we charge it for an hour or 2 hours or even 3 hours, it's going to take a long time, but it's better for the battery because it doesn't heat it up as fast. But if we got to get someplace and we just want to test the battery, we can charge it for at 100 amps for only 10 minutes, 5 minutes. It'll heat up the battery quicker, but at least we get a quicker charge out of it. Depends on the time, how much time we have. Okay. So there's different options to charging batteries. We're definitely not trying to get the battery too hot though, because that's when we can damage it. If we're ever testing parasitic draw, which is the amperage that is taking that the vehicle is taking from the battery when the vehicle is off, there's always a small, tiny little bit of amperage that is the vehicle is taking from the battery at all times when the vehicle is off. Okay. It's very, very small. We're talking 30 milliamps, maybe 20 milliamps. Hopefully not, no, hopefully no more than 50 milliamps. But that's okay over time. So we're not talking, you can't leave your car there for 1 year, come back in a year and expect the battery to be good because it's not, it's going to be drained by that point. But for the most part, most batteries, if you leave your car there, the vehicle should be okay with, I'd say a couple months, 2 months, maybe 3 months, depending on the vehicle, should be okay. You should be able to get in the car and start it up, and the battery should not go dead. If you're talking like 6 months or more, maybe, maybe anything over, say, 4, 5, 6 months, you're it's a hit or miss at that point. It depends on the vehicle, depends on how good the battery is and what the temperature is outside over that period of time. But naturally, you should be able to just park your car for a day or two, start it up, and no problem. If you have a parasitic draw, meaning that the vehicle is drawing too many amps from the battery when it's just sitting there with the car off, you're going to have a parasitic draw that can drain the battery. Now we can test for this, and there's a couple different ways to test this, but I use a multimeter. That's probably the best way to test with it because it's very accurate. But it does require you to disconnect the battery cable, and that's what this tool is here. This tool is for you to disconnect the battery cable. If you have, say, two vehicles, like one is your weekend car and one is your daily driver, you might want to install this on your weekend car, so to say, because you may not drive it every weekend and you don't want your battery to go dead. So what you can do is you can turn, you see on the top here, you can turn it off or on, meaning you can disconnect the battery or connect the battery. So if you disconnect it, then the car cannot drain any electricity, drain any amperage from the battery because it's not connected. Okay. Instead of going in there every time and physically disconnecting the cable, this is a quick disconnect, okay, from the battery. It can be used for testing or for storage as well. Okay. This is if we're going to connect jumper boxes or jumper cables. So I want you to really read this and go through it. I'm not going to go through it, but I want you to read this, maybe pause the video and go through this because this may be on the quiz. Okay. On some batteries, well, most batteries, I should say, especially if you buy them new, they're going to have a date on them. Okay. Now, that's the date that it was built. Now, it goes by month and year. So when you buy a battery, make sure you buy one of the newer batteries. If you're buying a battery that's 6 months old, has been sitting on the shelf for 6 months already, and you're gonna go buy it and they want to sell to you, I would, if you're okay with buying it, I would highly recommend that you ask for at least for a discount because it is old. Um, But yeah, batteries, they do have dates on them. And again, a battery should last roughly 3 to 5 years. I would say 3 at the minimum. Honestly, 4 is probably more likely nowadays. And even 5 is pretty good. You know, if a battery lasts you 5 years, you're doing good. That's a good battery that lasts a good amount of time. I have heard of other batteries lasting longer, which can happen. I don't see it that often, but it can. Okay. And if we wanted to go back to that parasitic draw question or parasitic draw issue I was explaining earlier, we could, instead of using a multimeter, we could use an amp clamp or an inductive amp meter, which is what this unit or this tool is we're looking at right here, this picture. We just put it around the cable, put it around the negative battery cable, and we just let it sit. We're looking for, again, no more than 20 to 30 milliamps, but in reality with new cars, because there's so many modules on these vehicles nowadays, it can go as high as 50. I've even seen as high as 70 milliamps, and that is okay. Okay. But yeah, this is another way to test for amperage drain. This is kind of an old picture here from an old vehicle. If you ever take your battery out and there's a message on the older radios that say code, that means you need a code to be able to use the radio. That was, they installed this and they did this to deter theft. Okay, so people wouldn't steal the radios, because if you stole the radio, you would need a special code. The only way to get the code, if you don't have it already, is to go to the dealership and ask for it, but you have to show that you're the owner of the vehicle, show your license and show your registration. Okay. So that's, if those is on older vehicles, if you see it nowadays, but it's not common anymore. Um, on This is just a example of where you can use a 9-volt battery. So if we connect a 9-volt battery and we connect it to the AC outlet, if we have one on some of the vehicles, a lot of modern vehicles don't have it. They have USBs outlets nowadays. But if you had the old socket lighter type of plug, you could connect a 9-volt battery to it, and this could be used as a memory saver when you disconnect the battery and change the battery. Because when you disconnect the battery, what you're doing is you're removing all the memory from the vehicle. So meaning even from the radio. So the radio, when you connect the battery back up, you're going to reset all the radio stations and all that, or the customer would have to reset all the radio stations. Some people don't like to do that, and sometimes it loses memory, like I'll say on the seat memory and stuff like that. So one way to avoid this is to connect a 9-volt battery to the AC socket, or sorry, DC socket, if it has that feature. So not all vehicles have that feature though. And then locations of batteries. Where can the battery be located? They can be located. This is under the back seat. This is the picture we're looking at. So it can be under the back seat. It can be under the passenger seat. The most common places are under the hood and in the trunk. Okay, but they can be anywhere. Corvettes have them in the fender lining. All right, so you have to take off the wheel, the left front wheel. So there's different places where we can have them. All right. And then battery maintenance tools. These are some of the common tools that you would need. There's some wire brushes, some terminal tool to remove the terminals. That's what this clamp looking one up top here looks like. This is to remove the terminal, wire brushes to clean, stuff like that. Okay, these are very inexpensive tools. I think most technicians, as you start to work on vehicles, you would acquire some of these tools. Okay. And then here's our testing tools. So this is the Matco conductance tester. I showed you the Medtronics one earlier, or at least a picture of it. And this is a picture of the Matco conductance tester. This tool, I would estimate roughly probably around $250, maybe $300 nowadays. Could be more, I don't know. But this is a tool that, if you're going to be doing this a lot, that's something you could have in your toolbox, and that would be okay to purchase, especially if you're doing a lot of maintenance on vehicles. Because every time you do a maintenance, like a 30K service, you should test the battery as well. This Medtronics one to the right here, this is the bigger one. This goes with the GR8. Now, this one here on the right, that is a very expensive tool. You do not want to buy that tool. It's a couple $1,000s, and that's something like the shop would have. Okay. It's just, they do the same purposes. Yeah, the Medtronics one might be nicer and fancier and bigger. Maybe it's more accurate, but in reality, the smaller tool on the left, the Matco one, is going to be sufficient for 90% of our needs. So load testing batteries. So if we are to load test a battery, what you could do on older vehicles, and I'm talking like pre-96, if you have a vehicle that's before 96, you may be able to do that. You might want to check your owner's manual, check your own service information before you do that. I do not recommend load testing batteries on newer vehicles. Okay. If you are able to do that on your vehicle, and you have the proper tool to do it, which you would need one of these tools, which is a VAT, voltage and amperage tester. Um, you could do that, and some shops could do that on older vehicles. Okay, I'm gonna let you go ahead and read through this and figure out and learn a little bit about it. But again, we don't do this on newer vehicles. Okay. There was a video here that I will post on Canvas for you to watch. Okay. And now let's get into part two, cranking system diagnosis and service. Okay, so cranking system again is starters. If you want to take a break, there's a good time to go ahead and pause and take a break and then come back. Now, starting system. Now we're just looking at an exploded view of the starter and just going over some of the parts, maybe as a reminder from the previous module where we learned about this. Here's our armature. That's the portion that spins. There is the, there it is. There's our, what do we call our uh, permanent magnets, okay, that are the outside. Think of it as a stator and an alternator portion, okay. And then we have our gears, and then we have our solenoid here, which is very important because that's what pushes the gear out to be able to connect to the flywheel. All right, and that's just a quick review. Now, again, a picture of it. So our solenoid on top and our starter motor on the bottom. The bigger cylinder is our starter motor. The smaller cylinder is our solenoid. Then we have the battery cables connecting directly to the solenoid to supply power. Okay. What components or circuit can keep the engine from cranking? This is going to be a quiz question. Those are your three possible things that can keep it from cranking, meaning when you turn the ignition switch or you push the button, nothing happens, like zero happens. Okay. It's not that it cranks and it wants to start, but it doesn't start. It's that you get nothing, you get no noise, you get no turnover of the engine. Anti-theft, bad solenoid, or your ignition switch could be bad. Okay. And this is assuming that you have a good battery too. If you have a bad battery and none of that happens, then usually your lights on your dash won't even come on too. So there's other things wrong, not just your car not starting. Okay. With a bad battery. So those are your three answers, your three things that if you have a cranking that won't turn, meaning turn the key, push the button, nothing happens. Okay. These are the three possible things. Now, symptoms. Vehicle does not crank fast enough to start the engine, has a slow crank. Okay. So a slow crank, slow, meaning the engine is turning, but it's turning slowly. That's not an electrical problem in the sense that there's no power to the starter motor because the starter motor is actually working. Okay. That's when we're going to start looking at the battery. We're not looking at the starter itself because the starter is working because it's turning the engine, but it's turning it slowly. Okay. We're looking at why is it turning it slowly? Maybe because it's not getting enough power, not getting enough electricity because the battery is discharged or bad. Or there could be something wrong with the cable, the battery cables themselves. Maybe they're burnt up, maybe they're worn out, and they're taking some of the electricity from the battery that was meant for the starter, and it's being lost within the cables themselves. So we want to do a voltage drop on the cable to see how much electricity we're losing, how much voltage we're losing from the battery to the starter. Okay. And those are things we would want to check with that. Now, slow cranking and excessive current draw. So we're going to put a current or an amp meter, inductive amp meter on the battery cable. Okay. And then we're going to crank it and we're going to see how much current. So on a traditional 4-cylinder engine, the starter motor should draw anywhere between, I'm going to give you a big range, anywhere between 40 amps to maybe up to, say, 90 amps, maybe even 100, depending on the compression ratio of the engine. Okay. So it's a big range, right? And I'm just talking about a normal 4-cylinder, 2-liter engine, nothing excessive, no high performance, anything, just a normal standard engine, roughly around there. Okay. Roughly around, let's say 40 to 90. Okay. Within that 50 amp range. Now, if it's drawing 150 amps, then there's something wrong. Okay. It should not be drawing 150 amps on a normal 4-cylinder engine. That'd be more for like a V6 engine. A V6 engine should draw 150 amps normally, but a four cylinder should not. And it's cranking slow. Okay, now we're looking at something maybe a little bit different. Now we're looking at maybe mechanical faults within the engine. So something's wrong with the engine. You could have a bent connecting rod. You could have a spun bearing, meaning it's putting a load on the starter motor. It's not allowing it to turn effectively, and it needs more electricity, the amount of current to be able to turn. So it's drawing more from the battery, which is not good. So something mechanically could be wrong with the starter motor or within the engine itself. Okay. So that's what we're looking at when we're talking about slow cranking and excessive current draw. The other thing too is we want to do voltage drops. So here's 3 different types of voltage drops that we could do on the starting circuit. Now, when we do a voltage drop, what we're doing is we're checking how much voltage is lost within the wire, how much voltage between the battery and the starter is being lost. Okay, we don't want any to be lost. We want zero, as close to zero as possible. Now, if you notice the meters how they're connected, they are connected only between the wires. They are not connected, including they do not include the battery or the motor itself, the starter motor. We're checking the connections with this is what we're doing. So we're checking how much voltage. I'm going to do the first one here. So I'm going to do this meter here, okay, on the left. We're checking how much voltage is being lost between the big red cable between the battery and the starter solenoid. How much voltage is being lost there? So if this wire is good, it shouldn't take any voltage or very, very little. If it took, as it says up here, 0.5 volts, that's okay. It's not bad. What if it was to take 1.8 volts? If we have a battery that makes 12.6 and we have a voltage drop of 1.8, how much would the starter get? Okay, little math real quick. So 11.4, is that right? 11.4 volts. Is 11.4 volts enough to start the engine? I hope everyone said no. Okay, so 11 uh, uh 11 or sorry, that's actually 10.4. But 10 point 10.4 is not enough to start the motor. Okay, even 11.4 is not enough to start the motor. So regardless, this is way too much of a voltage drop. Even if we took 1 volt, now we're at 11.6. Is 11.6 enough to start the motor? No, 11.6 is not enough to start the motor. So we can't, we should not even allow that 0.5 really. 0.5 is, we're talking about the maximum. That is the maximum amount of voltage that can be lost within a wire. In reality, it only should be like say 0.1, 0.2. That's it. Okay, because we don't want to lose a lot of voltage between the battery and the starter motor. And that's what we're checking here. How much voltage is being lost? Okay, so we can check voltage drops on all the cables, and then that can help it determine, all right, is it the cables? Is it the battery? Is it the motor? Is it the engine? It tries to help us to narrow down where the issues are. Okay. And this is on the ground side. So if we wanted to, I'm gonna go back with just one picture. And the one that this next slide is showing is this meter right here. Okay, this connection right here. Okay, I just circled it real quick. Now, this picture is showing that over there, we're only looking at, we should only lose 0.2. On the ground side, if we want to check the ground connection between our negative post and the ground connection where it leads to, it could be to the block or it could be to the chassis. We only want to lose 0.2, which is very, very tiny amount. We shouldn't be losing a lot at all on the ground side. Okay, and that's what this is explaining here and showing here as well. Okay, in the last couple slides here, again, we could use this is more for like if you're going to do a physical test or actually do the test on the starting system, we want to use the GR8, which we do have in our lab area. Okay, and we would do that in the lab portion of the class. And we would check starter draw, we would check amperage, we would check battery capacity, we would check alternator output. We would do all those checks with the GR8 on a physical car with it running and working. Okay. And to do that in the GRA, we would go to the system tests. So if you're interested in that, then be sure to take the lab portion of the class if you aren't already. Okay, and then this here, I'm not gonna go over every detail, but this explains to you how to check the starter amp draw. So you will need an inductive ammeter, which is this tool here. There's multiple different designs and different makes that make this. This happens to be a Fluke. You don't have to get this exact tool because this one is kind of expensive, but you can get a different tool as long as different brand, as long as it is an inductive amp meter. That's what you're looking for, inductive amp meter. And that'll help you to be able to determine the amperage of a starter motor as you're cranking it. Okay. And then how it works and how you do it is explained here. All right. So go ahead and pause the video if you need to, and go ahead and read through that and write that down. Now, the last couple things, the last two things we're going to go over. I think there's two more things. The last two things here, again, write this down. As long as so sometimes we can hear a high pitched noise. So if we're hearing noises when we're starting the vehicle, and that's only when we're starting, not when it's just driving down the road. If we're hearing noises, we're going to look for the gear where the solenoid kicks out the gear of the starter motor and touches the flywheel. Okay. That's the only place we're really going to find. I shouldn't say that's the only place, but that's the most common place we would find noise. Okay. And that's something we'd have to check first before we start digging around on other stuff and looking around, because that's going to be the most common thing. Okay. If we were to find noise, more than likely it would be with the gear from the starter motor touching the gear from the flywheel. Right. And then the last slide here, a bench test. So a bench test there's a picture of it here, and we do this in lab. I show students how to do this in the lab portion of the class. When the bench test is done, what we're doing is we're actually engaging and operating the starter motor on the bench. That's why it's called a bench test. If you notice here that the starter motor is in a vise, okay, so the vise is down here, and here's our starter motor, and we have a jumper box, we have a positive cable, and then we have a ground down here. So we can connect it to the chassis or the base of the starter as well. And connect it to the vise because the vise is connected to the starter. So there's multiple ways to connect the ground. But we have a power, we have a ground, and then we have a vise holding the starter motor. And then we're gonna have a jumper cable that would connect the S terminal to the B terminal. And then we would have a little push button, or you can have the starter, the switch on the actual jumper box too. We have one of those. Okay. So there's multiple ways to do this. But what we're doing is we're actually physically testing the starter motor to make sure it turns and spins on the bench before we put it in the car. And after, if you finish like rebuilding a starter motor, you'd want to bench test it then as well, just to make sure it works. Because you don't want to get a new starter motor from the parts store and then put it in and then find out it doesn't work. So we want to take it from the parts store. That has happened before. Not all parts stores sell 100% perfect parts. So you can get a bad part from the parts store that is supposed to be new. We can get a starter motor, we put it on the bench, we test it, connect it, make sure it spins, make sure it works. Then we can put it in the car just to verify. It may still be bad when we put it in the car, but the likelihood of that is going to be very, very, very slim. Okay. So that's what this is showing here, is just a simple bench test on testing a starter motor before you put it in the car. Okay. And so that is it for this PowerPoint. Okay. Hopefully you've enjoyed it. If you have any questions, as always, make sure to reach out to me. Thanks very much.